Okay, we're on derivative of exponential functions. The first, because we have, at least we've known that exponential function is the inverse of logarithm function, and we know we have natural log, that's logarithm to base e, and logarithm to other bases. So we'll start with the derivative of e raised to the power of f of x. So the derivative of anything, you know this is an exponential function. The derivative is just f prime x e times f of x. That's it. So example, if someone asks you to find the derivative of e raised to the power x, the answer, if you differentiate x, is 1 times e raised to the power x, which is e raised to the power x. Or if you ask to find the derivative of e raised to the power sine x, that's if you differentiate, if prime means the derivative of sine is cos e raised to the power sine x. So it's very simple. If you ask to find the derivative of maybe e raised to the power x squared plus 3x plus 5, the answer is derivative of this is 2x plus 3 times e raised to the power x squared plus 3x plus 5. So that's the first thing. So let's enter the second aspect, when the base is not e. So any other base like a, any number, any constant. So what if we are now given an exponential function that the base is not e, that is any other number except e, maybe 2, 3, 4, 5. Because we know that the inverse of logarithm function is exponential function. We know that the base could be any other number or base e. That the answer, the derivative is the same as f prime x a raised to the power fx after multiplied by ln a. That's the logarithm of the base. Yes. If you look at the previous one, we did not multiply. As long as it's natural log, it's just f prime x e of fx. But this one, after you've written that, you need to multiply by the logarithm of the constant. Why is it so? Okay, if you could remember from the laws of logarithm that if you have b log bm, that the answer is m. Yes, if you could remember the relationship, if you have an exponential function that the power is a log function and the base of that log function is the same as that of the base of the exponential function, the answer is this, and this must be greater than, where m must be greater than 0. So using that same knowledge, I can write a raised to the power fx as e log e a of fx. Yes, because e, so we have this bbm, and we also remember log base e, we can write this as ln, so ln a raised to the power fx. So we are still on the right track. And again, using laws of logarithm, if you could remember that if you have log abc is c log ab, do you remember this law? So I can write this as e fx ln a. So I can write this is now this. So if someone asks me to find the derivative of a raised to the power fx, is the same as the derivative of e fx ln a. And do you remember the derivative of exponential function? Look at this. The derivative of this is the same as, we'll multiply the derivative of the power, the exponent, by the original function. Do you see it? So if you differentiate the derivative of this after multiply by the original, so that's what I'll use here. So I now differentiate this, and again this is a constant. Example, if someone asks you to differentiate 3x squared, it's the same thing as differentiating x squared after multiplying by 3. So the derivative of x squared is 2x, so 3 times that is 6x. So I want to differentiate this, and the derivative of this is now f prime x ln a. Yes, because this is a number. So the derivative of a number, just a constant, is the same. Derivative of a function with a constant is the same thing as the constant times the derivative of that function. So after I multiply by the original function, which is a e raised to power fx ln a, using this knowledge here, derivative of this times the original function, derivative of this, which is that, times the original function. So we're on the right track. So which is the same as, we can go back, if you this e raised to power fx ln a, so I can replace this with this. So this is just f prime x ln a times a raised to power fx, so which could be written as, therefore that's what I've proved now, that we can write it as f prime x a raised to power fx after multiply by ln a. So we are correct. So example, now if someone asks you to find the derivative of, maybe find the derivative of 5 raised to power x squared plus 3x, without wasting time, the answer is differentiate this, which is 2x plus 3, 5 raised to power x squared plus 3x after ln 5. That's it. See it. A is 5 here. Fx is x squared plus 3x. So derivative of fx, which is x squared plus 3x, is 2x plus 3. The original function, which is this, times ln 5. So that's it. So maybe we're asked to find the derivative of, maybe 12 sine x. The answer is, the derivative of sine is cos times 12 sine x ln 12. Yes. Or maybe we can write it as constant first, ln 12 cos x times 12 raised to the power sine x. Or depending how you want to write it, or 12 sine x ln 12 cos x. So anyone, I think this will be better. Or maybe if you're asked to find the derivative of maybe 7x squared plus 5x plus 8, the answer is, what's the derivative of this? 2x plus 5 times 7 raised to power x squared plus 5x plus 8 ln 7. Or maybe you write it as 7x squared plus 5x plus 8 times 2x plus 5 ln 7. So anyone. So that's the answer.